Co-ordination entity. A complex ion is an electrically charged radical or species carrying positive or negative charge in which the central atom or ion is surrounded by a suitable number of neutral molecules or negative ions. For example, CONH3 for Cl2. The complex ion carrying a positive charge is called cationic complex. For example, NiNH3 6 2 positive. The complex ion carrying a negative charge is called anionic complex. For example, PtCl6 2 negative. The complex ion carrying no charge is called neutral complex. For example, NiCO4. Ligands. The neutral molecules or ions that surround the metal ion in a complex are known as ligands. Ligands are normally polar molecules which have at least one unshared pair of valence electrons. They get attached to the central metal ion by a coordinate bond. The atom in the ligand which is involved in the formation of coordinate bond with central metal atom is called coordinating atom or donor atom. A ligand may contain one or more donor sites. Depending upon the number of donor sites, the ligands are of following types. Unidentate with one donor site, for example, carbonate ion. Bidentate with two donor sites, for example, oxalate ion. Tridentate with three donor sites, for example, triethylene triamine. Tetradentate with four donor sites, for example, triethylene tetraamine. Hexadentate with six donor sites, for example, ethylenediamine tetraacetate ion. An atom can have only one donor site, but a molecule can have more than one donor sites. Denticity and chelation. When a multidentate ligand simultaneously coordinates to a metal ion by more than one donor site, then a ring-like structure is obtained. This ring-like structure is called a chelate ring. Pt trion 2 positive is an example of chelation. The ligand coordinates to a metal ion to form a ring-like structure is known as chelating ligand. The number of such ligating groups indicates the denticity of the ligand. A didentate ligand is symmetrical if the two coordinating atoms are the same. If the two coordinating atoms are different, it is unsymmetrical. Some properties of ligands. Inner metallic complexes. When ligands possess both neutral and anionic groups, coordinate with metallic cation, they form complexes in which both the coordination number and charge of the cation are satisfied simultaneously. Flexidentate character. A polydentate ligand may not necessarily use all its donor atoms to get coordinated to the metal ion. For example, EDTA can act as a hexadentate or a pentadentate or a tetradentate ligand. Ambidentate ligands. Some unidentate ligands have more than one donor atoms through which they can coordinate to the central atom. Coordination sphere and coordination number. Coordination sphere. In the complexes, the central metal ion along with the non-ionizable ligands attached to it is called coordination sphere. The portion present outside the square brackets is called ionization sphere. Species present in the coordination sphere are non-ionizable. Species present in the ionization sphere are ionizable. Coordination number. The total number of ligands attached to the central metal atom in the coordination sphere is called coordination number of the metal atom. Coordination polyhedron. In the coordination sphere, ligands attached to the central atom lie in space in definite directions. It gives a definite geometry to the complex ion. This spatial arrangement of ligand atoms which are directly attached to the central atom is called coordination polyhedron about the central atom. The commonly observed polyhedra are square planar, tetrahedral, trigonal bipyramidal, square pyramidal, octahedral. For example, square planar polyhedra observed in PtCl4 2-, tetrahedral polyhedra observed in NiCO4, and octahedral polyhedra observed in CONH3 6-3 +. Oxidation number of central atom. The oxidation number is the residual charge that appears on the central atom when all other atoms are removed from it. The charge on a complex is the sum of the charges of the constituent parts. The sum of charges of the constituents is equal to 0 if the complex is neutral. The sum of charges of the constituents is equal to the charge on the coordination sphere for an anionic or cationic complex. The total electrovalent charge on the complex ion changes with the number of charged ions which may enter into coordination sphere to replace neutral molecules.